Let's build a machine learning model to predict the outcome of a very special game between the Steelers and the Ravens. Tomorrow, the Pittsburgh Steelers play against the Baltimore Ravens in the 14th week of the NFL Championship, so today we're building a random forest classification model to predict the winner. We're using this Kaggle dataset for our model, where each row is a matchup between two specific teams. Almost every single column after that is a specific feature or part of the game. But there is one final column, which is called the label, and it lets us know who actually won. So let's break down how to turn these raw numbers into a real prediction. As always, we start by importing all of the necessary libraries. We have pandas for data, NumPy for math, and default dict helps the code keep a running memory of the team so we can build things like streaks. Then we're importing a bunch of different tools from scikit-learn, our machine learning toolbox. These will help us pre-process the data, make the pipeline, build the model itself, and evaluate it. Alright, now it's time to load the NFL scores and the betting data into a data frame. First, we filter down all the seasons to 2002 onwards so the model is training on modern era football that is more similar to tomorrow's game. We remove all the rows where the final scores are missing and convert the schedule data into a proper date time. And finally, we're defining a target variable that the model will learn to predict. For every single game, we will set home_win to 1 if the home team score is higher than the away team score and 0 otherwise. And now that our data is clean, let's move on. Schedule_week is a variable that tells you when a game takes place, and this next block of code fixes the problem that it's not always a simple number. Regular season games have numerical weeks like 2 or 10, but all the playoff games like Wildcard or Super Bowl are categorical. This helper function makes sure that every single game does have a numerical value assigned to it by mapping wildcard games to 18, divisional games to 19, and so on and so forth. And once we apply this function to our schedule, we get a clean column called week_num that tells the model how far along in the season the game was played. Here we're defining another function called add team form features, and it's designed to walk through all the games in time order and attach form info to each one. For each team, a little memory object is created that stores 4 things: how long their current win or loss streak is, what they have been scoring recently, what they've been allowing recently, and whether they've been winning or losing in those recent games. For this next part of the function, imagine that you are watching the entire season game by game in order, but when you get to a new game, before watching it, you pause and check how the current team has been doing. And then you write all of that information down for the model before you hit play. This is extremely helpful for the model to track, so it can say at this moment in time, this is how strong the home team looked, and this is how strong the away team looked going into the game. In this last part, the current game is finally allowed to update each team's memory. The points scored and allowed are added into their recent histories, the result is logged as a win or loss, and the streak count is moved up or down. The function returns this enriched and up-to-date table, so we call it on our main data frame so the rest of the model can use these rolling statistics as inputs. Now that we have our rolling stats, it's time to decide what information will actually be fed into the model for each game. Here we are deciding to include so many features like when the game was played, whether it was a neutral field, the win and loss streaks, which two teams were playing, and so much more. And the important thing here is that we keep the home_win column as the only thing we want to predict. And finally, we're splitting the data into 2 parts. One is called X and houses all the inputs that the model is using to predict. The other part is Y, or home_win, and that is the label that says whether the home team won. And now we're finally splitting our data into training and testing splits. Here we're doing a time-based split, so every single game from 2002 to 2018 is training data. This means the model is allowed to look at both the inputs and the outputs of this split, find patterns, and learn new things. Then every game from 2018 to the present is part of the testing split. This part of the data will be locked away and kept absolutely top secret while the model is in its training stages. We will use it after the model is finished to test its performance on data that it's never seen before. The final step before we get to our random forest is processing the data. This is a pipeline that just tells our code how to transform different types of features. Numeric features will be standardized, while the categorical features will be 1-ha encoded. And the column transformer keeps track of which transformation we apply to which feature. And now it is finally time to train our model pipeline. You can think of a random forest as hundreds of tiny little decision trees, each with its own slightly different view of the NFL world. A singular decision tree works like a flowchart. It starts with its full dataset and asks yes or no questions to repeatedly split the data into groups. Once it has done this many times, it knows exactly what combination of questions usually result in the home team losing or winning. A random forest takes that idea and repeats it many times. In this case, we're repeating it 400 times because we're building 400 estimators or trees. And while we're defining this random forest classifier, we're also setting some other parameters to avoid overfitting. And now we're creating the full model pipeline, which includes first the pre-processing and second the random forest classifier. Now, every single time the model is fitted on a set of X and Y data, it will follow this exact same process of standardizing the numeric features, one-hot encoding the categorical features, and splitting the data into 400 decision trees so it can decide if the home team will win or lose. And that's exactly what we're doing for our training split. This tiny line of code at the bottom of the block looks so small, but it's really carrying the entire model behind it. So now we ask, how well can the model actually do in real life? It's time to evaluate it on that top secret testing data that's actually not so top secret anymore because we're feeding it to the model. Right here, we define two variables. yprob runs the model on the inputs of the testing data to get its predicted output. And ypred takes that probability, whether it be 0.2 or 0.8, and turns it into a hard yes or no answer. Here we're going with the default threshold of 0.5. So if the model's outputted probability is below 0.5, we predict the home team will lose. Then the model compares the actual labels from the testing data and the model's predicted labels and finds the accuracy, ROC, AUC, Breyer score, and creates a classification report. And here are all of the evaluation metrics and classification report for this model. Now we can finally apply this trained model to our specific matchup between the Steelers and the Ravens. We filter the original dataset down to games where the Baltimore Ravens were the home team and the Pittsburgh Steelers were the away team. And then we pass this part of the dataset into the model to get its prediction. And now for the grand reveal, it looks like the model predicts that the Ravens will win this Sunday with almost 72% certainty. That is an NFL random forest model coded in Python right in front of your eyes. So if you learned something from this video, then don't forget to save it for later and follow for more.